Hello class, in this video I'll be doing an application of level curves. Let's begin. So one application of level curves occurs in economics with the production functions. A production function is a function that gives the quantity z of an item produced as a function of x and y, where x is the amount of labor and y is the amount of capital, in appropriate units, needed to produce z units. And there is a special type of production function called the Cobb-Douglas production function. And that is z is equal to capital A times x raised to the lowercase a power times y raised to the 1 minus lowercase a, where capital A is a constant and lowercase a is between 0 and 1 but cannot equal 0 or cannot equal 1. All right, so here's an example. Production of a certain item is given by the Cobb-Douglas production function. Z is equal to x raised to the 3/4 power times y raised to the 1/4 power. X is the amount of labor in work hours, and y is the amount of capital in appropriate units. What is the production when 40 work hours and 12 units of capital are provided? Okay, so here we're going to substitute 40 in for x and 12 in for y. And we're going to evaluate that in Desmos. So the function's already typed in. So we want f of 40, comma, 12. So that's about 30. So we're going to round up to 30. The production level is approximately 30 units. Okay. Part B. Determine the relationship between the amount of labor and capital required for the production of 100 units. Okay, so for this problem, we're going to create a function that represents the level curve when z is at 100. So we're going to create a function for the level curve when z is equal to 100. So I'm going to substitute 100 in for z. And now we have to solve for y. So I'm going to raise both sides of this equation to the 4th power. And I'm going to show you why here in a second. So I'm going to raise this 100 to the 4th power. And I'm going to raise this expression to the 4th power also. Because when you raise a power to a power, you're going to multiply the exponents. So this is 100 to the 4th power is equal to the following. So 100 to the 4th power is equal to x to the 3rd power times y. So y is equal to 100 raised to the 4th power divided by x cubed. So this function is the function for the level curve when z is 100. For part C, if 40 work hours are available, find the amount of capital needed in the production of 100 units, and then sketch the appropriate level curve. So there are two parts here. We'll take care of this part first. Okay, so remember that X is the amount of work hours. Y is equal to 100 raised to the fourth power divided by x cubed. This is the level curve for 100 units produced. So to find the amount of capital needed when 40 work hours are available and they want to produce 100 units, we're going to substitute 40 in for x. And we can do that on Decimus. (100 raised to the fourth power) divided by 40 raised to the third power. And it looks like that rounds to about 1563. So this is equal to 1562.5, which is approximately 1563. So the amount of capital needed is approximately 1563 units, or 1,563 units. Okay, now we're going to sketch the appropriate level curve. So the level curve is y is equal to 100 raised to the fourth power divided by x cubed. So the vertical axis is y, and the horizontal axis is x. And we know that when x is 1, if we substitute 1 into this level curve, you're going to get 100 raised to the fourth power. So here's the first coordinate. And we do know a second coordinate. When x is 40, y is 1562.5. And if we take a look at the level curve, x cannot equal 0, because if x equals 0, then the function will be undefined. So we're going to have a curve that looks like this. So how would this curve look in a 3D environment? So here is an x, y, z grid. And the level curve is the curve needed for 100 units of production. So remember that z is units of production. So that is going to be 100. So if we go back to the previous problem, notice that the production function doesn't cross the horizontal axis, nor does it cross the vertical axis. So in the 3D form of this level curve, the level curve is not going to pass through the wall on the right, which represents the YZ plane, nor is it going to cross the wall on the left, which represents the XZ plane. And these dotted lines represent the asymptotes. Now here is 1 along the x-axis, and here is 100 raised to the 4th power. And we can do the same thing over here. Here is 40. Here is 1562.5. And the level curve is going to look like this. So the level curve, which is the solid black line, will be on the same plane as these two dashed lines here. So this is the coordinate 40, 1562.5, 100. And this is the coordinate 1, 100 to the 4th power, 100.